Chapter 2, Section 1. A couple introductory notes about what we're going to be doing. In Chapter 1, we're able to solve systems of two equations with two variables. In other words, a 2 by 2 system. And I taught 4 different methods. We solved by graphing. We used the y equals method, substitution, and then linear combination. And to be honest, linear combination is the one you're probably going to need to know the best. It's important that you have several different methods because one method might work for one system better than another method. So it's good to have several different methods available. Now the problem with those 4 methods is they really only work for a 2 by 2. Now you can, like especially linear combination or substitution, there is a way that you could use those methods, but it's not very applicable. You wouldn't like doing it. So what we do from there is, for the bigger systems, we got other methods. And one of them is called what I call Gaussian elimination, sometimes called the Gauss-Jordan method. But that's what we're going to study in this chapter, and we're going to be using matrices, and matrices might be, I would imagine most of you guys don't know what matrices are. There's a few of you that will, but I can pretty much guarantee what I'll show you with the Gaussian elimination you have not seen before. Be very surprised unless you've taken a finite math course or maybe discrete math or something like that. Okay, so let's take a look. Got an example here. This is the same one that's in the book. This is a real life example. It says manufacturing. The Upside Down Company specializes in making down jackets, sky vests, and comforters. The requirements for down and labor, down, if you're not familiar, is a material that they pack in to help insulate, so keep you warm when it's cold outside. So the requirements for down and labor and the profits earned are given in the following chart. Okay, so let's look at the chart. Okay, so this column is down, that's measured in pounds. Time, those are in labor hours, or just hours, you can think of hours. And then the profit, notes in dollars. So if you had a jacket, you would need 3 pounds of the down, and then you need 2 hours to put it together, but you'd make $6 profit. For the ski vest, you need 2 pounds of the down, 1 hour to put it together, and you make $6. And for a comforter, you need 4 pounds of down, 1 hour of time, and you make $2. And right away, when you start looking at some of this, you got a pretty good idea. Well, I want the biggest profit, so I'm probably going to make those 2. But sometimes you're limited on different things, and you learn how to make several different objects or items, and then if you run out of something, you can make the other whatever. Okay, let's go on. Okay. Each week the company has available 600 pounds of down. So I'm limited right here by 600. Okay, now I'm going to put 600 right here in that column. We'll come back to that. 275 labor hours. So I'm going to put 275 right here. It wants to earn a weekly profit of $1,150. How many of each item should the company make each week? Okay, so we're going to look at a method so we can figure this out. First of all, we need to define our variables. So I'm just going to say x, y, and z. Well, when you define the variables, you need to ask yourself, what are you trying to find? Well, I'm trying to find how many of each of these items I want to make so I achieve this profit. So we're going to let x be the number of jackets, y is going to be the number of vests, and z is going to be the number of comforters. So x, y, and z. And you could use any variables. There's some people that like to say, well, I'm finding jackets, vests, and comforters. I'm going to use J, V, and C. That doesn't matter. We've gotten the habit of just using X, Y, and Z all the time, and then it makes a little more sense when you're working your equations. It's probably easier to follow that way too. Okay. Okay. Now we want to find, I've got inequalities. Those should be equations. And that's really all we're doing. We're just setting this up. We're not going to solve the problem all the way through. Okay, but there will be three equations. And if you go back to here, we're going to have an equation for down, an equation for time, and an equation for profit. Each column has its own equation. So I'm keeping this here so I can use my chart, because that's going to dictate everything. So we know from the chart how many pounds of down do we need for a jacket. So for a jacket, there's 3 pounds. And how many jackets do we have made? Well, that's where a variable comes in. That's going to be x. Okay. Starting to get in a bad position here. Okay, and then for the vest, it takes 2 pounds. And that's going to be y. We made y of them. And then down for the comforter is going to be 4. And we got z of those. Yes, I crossed my z's. So the total amount of down used would be, well, I need 3 pounds for a jacket. We made x of them, so that's going to be 3x. Plus, for a vest, that's going to be 2y. Plus, and then 4z for the comforter. And how many did we have available for the down? We go back to here. There was 200. So my first equation would be 3x plus 2y plus 4z equals 200. So again, we had 3 pounds for the jacket. We made X jackets. So, you know, if we had 1 jacket, we'd use 3 pounds. 2 jackets would use 6. 3 jackets would be 9. 4 jackets would be 12. So you're simply taking 3 times X. That gives you the amount of down used for the jackets. Pounds for the vest, you're going to take 2 times Y, and pounds for the comforter, same thing, 4Z. To get the total, you're going to add those all up, and we know we want it to total up to, I got 200, it was 600, misread something, I'm sorry, change that to 600. Okay, so my first equation, 3x plus 2y plus 4z is equal to 600. Now let's go the same thing for hours of labor. So looking at my chart, it goes 2, 1, and 1. 2 hours for a jacket, 1 for a vest, 1 for a comforter. And again, we had X jackets made, Y vests made, Z comforters made. So same process we did for the down. It's 2 hours per jacket, and we got X jackets, so that's going to be 2X plus 1 hour here, and Y, 1 times Y is just Y. And I got 1 times Z, so it's going to be Z. And the total amount of hours I had available when I look back over here, 275. So we're simply going to take 2x plus y plus z equals 275. And that's my second equation. Okay, we've got one more equation. Okay, so now we're talking about profits. My profit column's over here. So for each jacket, I make $6. I'm going to make X of them. For each vest, I'll make $6, and I'm going to have Y of those. And for a comforter, the profit is 2, and I got Z of those. Okay. So I'm going to have 6x plus 6y plus 2z and we want a profit of $1,150. I'm supposed to leave that blank. So my last equation, the third one, I'm going to have 6x plus 6y plus 2z, and that'll be equal to 1,150. Okay, not terribly hard. So that gives us 3 equations. Okay, so from the down I had 3x plus 2y plus 4z equals 600. For my labor hours, it was 2x plus y plus z equals 275. And then my third equation I just found up here, 6x plus 6y plus 2z is equal to 1150. Okay, now I've done all of that. Now I'm going to show you what we're going to do with it. This is the last thing I'm going to show you in this lesson. Here's the 3 equations. I'm going to write a matrix out of that. So first of all, you can say, what's a matrix? And I will explain more about what a matrix is later on. By definition, a matrix is a rectangular arrangement of numbers, or sometimes say a rectangular array of numbers. So rectangular means we're going to be putting them into rows and columns. It'll be rectangular when you look at it. So my first row is simply going to be this equation. Take away the variables, take away the equal sign, take away the plus signs. So I got 3, 2, 4. and 600. So the first equation gives me these numbers. The second equation, I do the same thing. So I got 211, 275. And then the last equation down here, I got 662 and 1150. Okay, so I've created a matrix. Okay, notice that you've got a column, a column, a column, and a column. So there's 4 columns, and you've got 3 rows, 1 row for each of the equations. First row, second row, third row. When you put them in rows and columns, that's what they call rectangular. You'll also notice that it's got these, they're supposed to be brackets. I got round off because that's what the computer does, but they're supposed to be more squared off. Now it's starting to look more rectangular. Okay, so what did we just do here in this lesson? Well, I started out with some brief notes about what we were doing before and where we're going now. And then we had a practice or an example here where they gave us all the information, and what we have to do is take that information and put it into, first of all, equation form, and then transfer that to matrix. Okay, here's all your information. We defined the variables, and then I showed you the logic on how we came up with the equations. So I had an equation for down, equation for labor hours, and then my last one here, my last equation was for the profit. Those are my 3 equations, and then down at the bottom I took the 3 equations and wrote them in matrix form. And I'm going to stop there. That'll get you going on this chapter. As we go on, I will show you this Gaussian elimination, and pretty significant, so you're going to pay attention, make sure you get it.